Good afternoon and welcome to the last session of today on mobility and transportation. We are going to hear four very interesting presentations with a variety of topics in mobility and transportation, and we will have the questions at the end of this session. So I will introduce the first speaker for today. It's Egor Kotov. He has a background as a researcher and consultant in urban and transport development, including work with UNDP and the World Bank. He is now a doctoral researcher at the Max Planck Institute for Demographic Research and University Pompeu Fabra. His current work focuses on human mobility, disease dynamics, and socio-spatial inequalities. The floor is yours.
Thank you for the introduction. So basically this talk is a continuation of the last talk of the previous session, where Tanya told you about the data set, the incredible data set that is shared by the Ministry of Transport of Spain. And I will talk a little bit from the perspective of a researcher who uses this data and tries to make it more widely available and more widely used through software. So I'll start with this impression of national statistical offices. So this is how sometimes we researchers see you, as these cool kids playing with cool data sets years and years for years and not giving us the data. And this is us on the fence coming to conferences like this and seeing what kind of cool data you have had for the past 8 or 10 years sometimes, and we still don't have access to it. So this is completely different with this data set that you've just seen. So this is a data set of the Ministry of Transport of Spain. And this is what it actually looks like. So it's a pity Tanya didn't show you what it looks like. So this actually covers entire Spain, also Portugal and France, only for Spanish users, of course. As you've heard, it's hourly resolution for almost every day of the past 4 to 5 years. And this is an example of Barcelona with hourly flows. And as you can also tell from the previous presentation, each of these flows from A to B also has sex, age, income, purpose of travel at the origin, purpose of travel at the destination. And I'm using this data for my own research, which I'll be talking about today. But we've looked at how other people actually use this data. And we tried to infer what are the problems when they are using those, of data sharing, of code sharing, and how can we solve them with software. So we reviewed about 30-ish, 35 articles since 2020 that use this data. It was not easy to identify them. We did a systematic review to try to identify them. And most of them, they focus on epidemiology and COVID-19. And basically, because in this plot, they don't sum to 100, basically, these are the same articles. So basically, this data so far was only used for COVID, primarily used for COVID. There were some other uses as well. So we can see there's a lot of room for using other domains. But so far, it hasn't been used as much as maybe we would like to see. The years of this data that are available since 2020, basically this corresponds to the previous plot. Also, mostly 2020, 2021 data was used. So these new incremental data sets that have socioeconomic variables, the 2020 and 2021 data do not have socioeconomic variables. They have not been used yet. So we'll try to facilitate that as much as we can. Also, we explored the spatial resolution. The summary is essentially people want the highest spatial resolution possible. And in terms of time resolution, that was actually the previous plot. In terms of time resolution, people also want as much as possible. If you give them daily, they will take daily. If you give them hourly, maybe they'll aggregate it to days, but essentially they also would be very happy with hourly data. And then we also looked at whether researchers actually share the code to get this data and pre-process it before they begin the analysis. And here, actually wasn't as good as we imagined. Unfortunately, for most articles that we found, the code was not available to even analyze the data, but even for those where the code to analyze the data was available, unfortunately, so basically nobody shares the code on how they got the data. And many times researchers just rely on the person, whoever wants to try and replicate their code, to somehow guess how they downloaded data, which exact dates, how they aggregated it. And then, they just assume that somehow people will magically know what is the form of data before they run the analysis. So we tried to solve this problem. So data analysis code was also mostly not shared. What this means for academic community, for researchers, is that basically the analysis is not possible, reanalysis is not possible, reuse of analysis code is not possible because it's impossible to know how the data was acquired. And the final problem of use of this data in the wild is that the citation was also inconsistent. So sometimes people just use a footnote. Sometimes they just give link to the main website of the data provider. So basically, they're not helping other researchers to discover this data set, which probably reduces its potential reuse. And this is what the raw data looks like. So it's a bunch of CSV files. Each file is about 100 to 200 megabytes. When loaded in memory, they are about 2 gigabytes. And there is an XML file that needs to be parsed so that you can download the data. So this, you kind of imagine, it's not that hard of a task, but already that would take some time, even for an experienced person. So basically, you have to write custom code to download and import multiple days. And this is what we saw actually in some of the papers that were published along with the code. There was some long spaghetti code that basically downloaded days one by one. Then they imported the days one by one to process them and so on. So the variable names are all in Spanish, so not easily understandable without the proper code books to non-Spanish speakers. They are CSV files, so the data types are not guaranteed. Depending on who imports it and which software, the data types could be different, which may lead to mistakes. And again, because only realistically on a laptop like this, for example, which is about 5 years old, only 2 to 3 days could be fitted once into memory. This also limits the adoption. So what we suggest is a data package, a pretty popular thing, at least in our world, I think in Python maybe as well. And what this package does, essentially, like to simplify, this is a very fancy download code, but it does a little bit more than that because it also has an educational role. It's hosted on GitHub. It's completely open source, developed completely independent from actually the data provider. And what it allows you to do in these, basically, I would say one line of code, because the other ones are just setting up. This is how you get access to this data. So immediately, instead of spending some time on exploring on what is actually available and writing your own parsing code, you can start working with the data in less than 1 minute. What is even more important, the variables are already translated into English. We have also enriched this data set with some additional labels, also in English. And it's also structured, so the input scripts inside the package are actually SQL, and they control the data types that you get when you work in R or in Python as well. You can import this later in Python. And also, thanks to those SQL mechanics inside, you get some data control quality because the data types are enforced and the possible values for the data are also enforced. Very simple code can be used to summarize this data. This would be familiar to any R user. I don't know if there are many R users here, so I will not spend too much time on this code. And basically, you can get the flows in the form of a matrix, and you can get the spatial data which you can connect with the flows that you get through the package. And also the final thing that we identified with the problems of adoption of the data set is inconsistent citation. So we provide a simple function that provides you with a citation that is standard and then would later be easier for the ministry to actually find the articles that use the package to acquire the data in a consistent way and track further usage and adoption. The package is part of our Open Spain, which is, I'm not even sure it's an organization. It's more like a club of our package creators for different Spanish data sets. It's part of our Open Spain. On the website of the package, we have extensive documentation. We have translated most of the data dictionaries that were originally in Spanish, and we provide original variable, translated variable, and what we have or have not done with it, and what kind of data type we assign to it. And we have several guides on how to create visualizations, including those interactive visualizations, which you can do essentially in less than 2 to 3 minutes in R if you go to our website. What else? Yeah, so the package is not just a package, it's more like a small ecosystem-ish of packages. So we have our friend packages, Flow Mapper and Flow Map Blue, which were published in a way thanks to our effort on developing spanishoddata data. Basically, we nudged the developers of these packages, please put those on official R packages registry called CRAN so that we can reuse it in our package. And I'm also co-maintaining the Flow Map Blue, which are these cool packages that allow you to do those flow map visualizations. Yeah, this is just documentation. I'll skip to the interesting part, which is how we deal with the fact that this is a huge data. So how do you analyze this huge data on a laptop like this, which is 5 years old? So the secret is DuckDB, which is similar to the thing that was mentioned today, which is Arrow, which should be used internally in INE. And what DuckDB allows you to do, if we take into account like an average 5-year-old laptop with 256 gigabytes of SSD storage and 16 gigabytes of memory, which may be optimistic, and maybe your data set fits on your SSD. Maybe you have to buy an external SSD. Basically, it allows you to do almost any kind of data summaries using your SSD because it's fast enough to read the data and to do aggregation kind of on the fly in chunks. And so you can do the summaries very easily using just classic dplyr syntax that is available in R. And the interesting thing happens when you kind of run out of memory. So if the aggregation that you're doing does not fit into memory, DuckDB is actually smart enough to do what is called spillover onto disk. And basically, the compute in a way is made on your SSD. So the results of the intermediate computes are stored on SSD. And the summary is returned back to your memory, so you almost never run out of memory. And the data set of this size, which in total for 5 years is more than 500 gigabytes, I think, you can actually analyze it on a laptop like this. You can do the summary, for example, total number of all trips across all days in about 40 minutes. Like, I know it's slow, but it's still doable on just a consumer laptop. The syntax to take advantage of this DuckDB magic is simple dplyr syntax that is probably familiar to any R user. If you're not R user, sorry for the code on the slides. And in terms of the speed advantage, so DuckDB, which is the engine of spanishoddata data that I'm talking about, it is very fast, even on CSV files on the left, on Parquet files on the right, but it is the fastest if you convert the data into DuckDB format. And what our package does, basically, it provides a one-line function to automatically download the data and convert it in the best possible format by default, which is DuckDB, which will provide you even on a simple laptop, again, with the best experience of analyzing this data, utilizing all of your processing memory on your available cores on your laptop. And if we zoom into this DuckDB thing, and if we zoom into here, so this is a combination of the tech specs of a 3 to 5 year old laptop. So this is like exactly in the ballpark which we're looking at. Basically, you can run the analysis almost as fast for certain queries as you would even if you had even more than on this laptop. So you actually don't need that much for big data analysis. This is a 40-second video, which is 2x real time. It is sped up a little bit, but basically we also provide an interactive playground for the package and the data, where if you paste the 3 or 4 lines of code in about 30 seconds, so this is 2x real time, and the code is on the right, the one that I pasted, basically you can get a summary of a number of trips for 1 day by age and sex, and in the end, it's almost done. You are just getting a table, and this is the table. So this is super accessible to anyone within minutes. And these are the kind of visualizations that we made during the 30 days map challenge last year. So we're trying to popularize it through this way. We also did 2 summer workshops at conferences in Salzburg. Also, we had a long list of participants, 20 people signed up for this workshop, and also at International Conference for Computational Social Science. I'll skip the rest of it because basically I talked about it. To finish this off, the package has been downloaded over 2,000 times in about 9 months since it's been released. To put this into perspective, a similar package to access just basically the boundaries of Spain, administrative boundaries, has been downloaded 14,000 times, but it's only 6 times more than the mobility data. So I think the interest is there. And I will just do honorable mentions of the previous projects that also focus on similar things. And I'll finish off with that.
Thank you for not only highlighting challenges that researchers are getting into when accessing data, but also for providing solutions.